welcome back, everybody. Okay, so I can have your attention. We're gonna get started. Okay. But this room tends to be really loud, so I'm going to ask everybody to not talk when Professor Chong or I are talking. We're going to be really friendly about that for the first while, and then we'll be increasingly mean. So you don't really want to see that. So please stop talking now, because it's really hard to talk over you. Okay, apply peer pressure to any of your neighbors who are still talking. Okay. Welcome to ECE 297, Software Design and Communication, which we think will be quite exciting for you. Design is very important, communication is very important, software is very important. So we really have three levels of importance in this course. And again, we're really looking forward to it.
Okay guys, so this is a software design and communication course. So we thought we'd start out by just asking you for some feedback on Professor Betts's communication style. And this is a good opportunity to practice looking at how the mics and everything works here. So in the last 30 seconds, what was your impression of Professor Betts's communication style?
A07, can I go to you? So a quick tutorial on microphones. If you want to say something, push the back of the microphone. Don't push the top of it. It's actually the little spot behind it. If you go, oh my God, I clicked on it and I don't want to, what do I do now? Hold down on that back spot for about 3 seconds, it'll turn off again. If it's red, it means we know you want to speak. If it's green, it means you're actually talking to the whole class. So if you're complaining to your seatmate, you're complaining to everybody when it's green. Okay, so I'm going to start with A07. We're going to take you. Actually, I somehow turned on C11. C11, you're on the air. So C11, you're over there, I think. Your microphone should be green.
Accidentally pressed the microphone, so yeah.
Oh, it was an accidental press. Okay, we'll let you off. So A07. You're on the air.
Yo, yo. Hey, yo.
Okay, no, speak loudly into it. It's good testing.
I think you're wonderful.
It's not very critical, right? I think we're talking about that 30-second bit that we just did at the start. Yeah. A09.
Give me 1 second. Okay, A09. You're going to be on in a second, but wait till it goes green. Now you're on.
I would say the communication style is very assertive and direct.
Assertive and direct, okay. So were you guys looking at the part where he, just before the introduction to the course, where he was telling you the ground rules, or when he started talking about the course itself?
Oops, let me turn you on again. Sorry about that. And speak really loudly, big voice.
Mainly when he started talking right before he gave the introduction.
Ah, that was a real contrast, right? I think you should have been able to see that Professor Betts is a very good speaker, right? A good lecturer. But when he started to talk about the course itself, in the introduction to the course, did you notice a change or a shift in the way that he was speaking? What sorts of things did you see?
Do you want to take a shot at it, or do you want me to go to another person?
Sure. So when he started talking about the course itself, it was more formal, or I guess generic, as we'd expect from all the other courses we've taken. Like the introductions are generally the same. It's not very creative or new. Does that make sense?
Okay, so not very creative or new, and I think what you could see is elements of body language as well. Professor Betts started looking down instead of making eye contact with you. He started speaking in a much more monotone manner, and and in a way that wasn't particularly assertive. Now, you can very easily contrast the style that Professor Betts speaks with because you saw the kind of clips around that little bit, okay? And what we wanted to do with that little bit is to show you the difference between what it's like to be spoken to with an effective communicator versus someone who is less effective, and the importance of communication strategies and techniques over the course of your career, right? And definitely in an oral presentation setting. Now, there's a couple of reasons why we started with that, okay? One of the reasons that we started with that was that we wanted to show that, you know, introductions are really kind of important in establishing a speaker's credibility and framing how you understand or how you respond to a certain lecture or presentation. And in fact, there's research, or there's quite a bit of research in the technical communication field that kind of bears this out. So if we look at an article from Technical Communication Quarterly about exordial techniques in informative oral presentations, this was a piece of research that looked at how people respond to different types of introductions. And what we saw there was that their finding was essentially that a good introduction was able to do a couple of things for the listeners involved, right? They made the audiences more likely to listen to a speech, think more highly of a speaker, and understand a speech better. Right? And that's very important. And this was something that they found that the audience made a judgment on in less than a minute, which is why we wanted to stop that at about 30 seconds, right? We didn't want you to make a judgment on the course or the speaker, but we wanted to be able to demonstrate the kind of importance that good, or the impact that good communication can have, okay? Now, the other thing that I wanted to show with this article is that technical communication is a field of study, right? There's this journal, Technical Communication Quarterly, but there's also a whole bunch of other journals that document the research that people do into what are effective communication techniques. Now, I know you guys have been taught technical communication already, engineering communication in APS 111, 112. One of the things I'm going to talk about today is how what we're going to do here is going to be a little different from that, okay? But I did want to show you that it's going to be informed by research, right? So technical communication is not just something that's taught, it's something that's researched and studied, just like hardware and software engineering, and it's the findings from that research that we hope to translate into the practices that you have as the communication practices that you have as an engineer. Now, you might ask, why would somebody want to study technical communication? It's not the most exciting field that you can think of, but one of the key reasons is essentially just the mountains of documentation and communication that an engineer has to do, right? There's a ton of document types that I've just listed up there that are going to be part of a software engineer's vocabulary and workflow. Okay, and that's not even counting the kind of general day-to-day group communication that you'll be doing over the course of the next little while. Okay, now engineers have themselves acknowledged that this is important. So how many of you know about the IEEE? How many of you are members? Student members? Okay. Well, I mean, the IEEE is a really important organization that you should know about, right? It's a professional society for electrical, computer, electronics engineers. And what they do is they provide training, they support research through their journals and conferences, they set standards, right? And within this IEEE community, which is a huge community, by the way, it's staggeringly large. There is also like subgroups or smaller communities, and I'm part of one of those, right? And one of those is the Professional Communication Society. So even within IEEE, there's this acknowledgement that there's the importance of professional communication requires that there's a group inside IEEE of academics, teachers, engineers who are really interested in communication, but also people whose jobs it is purely to do technical communication, right? Those practitioners that I'm talking about. And we do the same sorts of things that other IEEE societies do, which is training, research, we do run conferences and meetings and standards, okay? And so you can see on our website that there is a set of resources. So there's a recent article on what Aristotle might be able to teach us about engineering communication. There's a case study that's published in our journal. And so there's a bunch of resources that are available for engineers there, not just student engineers, but actual practicing engineers who are with IEEE. And we have, of course, the Transactions, which is an academic journal. We have an annual conference where all of this is studied. And I'm bringing this up just because I wanted to show you where my community is and where I come from. So that field of professional communication, and particularly engineering communication, is where I come from. I've been in the faculty of applied science and engineering for about 16 years now within the engineering communication program. Currently, I'm the director of that program, and I'm the associate director of undergraduate programming for ISTEP, which is the Institute for Studies in Transdisciplinary Engineering, Education, and Practice. It's a real mouthful. Okay. Now, I've done a ton of teaching in Civ, quite a lot of teaching in engineering science, and some teaching in ECE, and I'm really excited to really get started with you this term. Okay. Now, I've worked prior to that as a trainer and a consultant in industry with companies like CGI, Autodesk, and Hatch. So I've run some courses for them. And why I was referring to that IEEE Professional Communication Society as our society, I'm actually serving as the president of that society for the next couple of years. So I can tell you all about what we can do and what we can help you with, and I'm happy to be here to start this course with you, okay?
Thanks, Alan. So that's quite impressive. So you have the head of the IEEE Professional Communication Society teaching you communication. You can pretty much list that on your CV. So let me give you quickly my bio. And yeah, hopefully you notice, I'm actually a little disturbed that some people maybe are quiet. Hopefully you did notice a difference between how I started, in a monotone, not looking at you, meandering. You can tell me at the end of the course, in the course evaluations, if you go, you know, I didn't actually see a difference. That was the way the whole lecture was. That's, the idea is there was supposed to be a contrast there. And as Professor Chong said, you lose your audience very quickly, which is why we only want to do it for 30 seconds. Okay, quick bio of myself. I'm going to go through the first few slides pretty quickly because I did a seminar in the fall on 297 which covered some of this. But my bio is I've had experience in a startup to design both hardware and complicated software, a CAD system. I worked 11 years at Altera, which is now part of Intel, running a big part of their FPGA division, both the hardware architectures and the CAD tools. So in 241 and 243, when you use Quartus, there's a bunch of my code inside of that. And ultimately, so at the startup, I was leading a team of about 10, 12 people. At Altera Intel, larger teams, bigger corporation, about 100 engineers. And I've been a professor for 11 years, working on a variety of projects, some computer chip design, so hardware, different software programs, usually focused on optimization and difficult problems for either computer chips or some for medical applications. So I've got, the reason I'm telling you that is it's important when you're learning a very practical skill like design, I think, to have someone teaching you actually has experienced it. And I have experienced design at multiple levels, smaller teams, bigger teams, open source. Okay, so what are the course goals? Get experience in design and project management. Okay, so design is creative. It's difficult to teach someone how to be a good designer. Experience is probably the best teacher. I'm going to give you a project and let you learn some of your own design skills, give you some tips along the way. You're going to work in a team, and that's another skill that you have to develop. How do you work effectively in a team? How do you get through conflict? How do you organize yourselves? Almost all real projects in industry and academia are done in teams, so you have to learn how to do that. We're going to use agile software development. It's the dominant way people design software systems and increasingly other systems. Focuses on get something working and iterate rather than a lot of upfront planning. As Professor Chong said, you're going to enhance your communication skills, both written and oral, and a big focus is making sure it's clear and memorable, not just that you're writing a lot of grammatical text. And you're going to learn some of the skills that go with software development in particular, tools like Git, a debugger, unit tests, and code sanitizers. Don't worry if you don't know all these terms, these are the things we're going to teach you. How to choose the right data structures. So in ECE 244, you learned how to code some of the basic data structures. Here we don't worry so much about that. It's more how do you choose the right one? Link them together. Graphics, so how do you visualize a complicated city map? How do you make a nice user interface? And some algorithms to solve difficult problems. The lectures and tutorials are going to cover the principles, key skills. You should come to lecture and tutorial. I'm not saying that just because it's lonely for Professor Chong and I if no one is here but us. The course is much more difficult if you don't come and get that information. We will, to accommodate people who learn by looking at things multiple times, or maybe you can't make it that week, we will record the lectures and tutorials and post them. The course text, as Dr. Chong said, is made to stick, how to make things clear and memorable. He'll talk more about that in a while. You're expected to know the lecture and tutorial material and the first 6 chapters of Made to Stick. So there isn't a final exam, but those things will help you do the project, and we will also ask you questions about them in your presentations. So if you basically answer, I don't know, I never cracked a book, and I don't know where the lecture is, you won't do very well on those questions. Okay, so that's what we're going to teach you, but in a design project course like this and communication course like this, you're not going to learn just by listening to us. You're going to learn by doing. So you're going to develop a complicated C++ software application in a team of 3. You're going to write 2 documents. You're going to present 2 presentations. The more you put into this, the more you're going to learn, okay? Because you won't get nearly as much out of the course if you just listen to the lectures and tutorials. You really have to get your hands dirty. You do have to balance this though. In a design project and in communication documents, you can't make them perfect. There's a point at which you say, that's good enough, I'm out of time. And that's actually important to realize. If you have a perfectionist tendency, one of the ways you fight that is you actually put a cost on your own time. You say, if I polish this thing to the next level, but it takes me another 20 hours, is that actually perfect? No, that is a very stupid use of my time. It's only a little bit better. So you got to balance it with the other courses. And we don't expect perfection, right? If we gave you a project where everyone could make a perfect project, then it's not a very interesting project. There's intentionally room for some differences, and you got to decide when it's good enough. The lectures are going to give you the key concepts, but not every answer. Now, why is that? Sometimes students say, well, why don't you just tell us? So you're telling us algorithms. You told us a few different algorithms and some choices. Why don't you just tell us this is the best algorithm? Why don't you give us a pseudocode? In fact, why don't you give us most of the code? It's because you won't learn that much that way. You have to learn to develop the ability to work independently, the confidence to work on open-ended problems, and the tenacity to debug a complex system. So your software will not work the first time. That is the way software is. That's actually the way any complicated system is. A key learning is how do you debug that? How do you make it work? I was talking to one of my colleagues, Dr. Rose, today, and he was pointing out that he was emphasizing to his 243 class that engineers make things work, and that is true. No one will hire you in academia or in industry to say, I'll kind of make something broken, and then I'll ask one of my coworkers to make it work. You do ask for help, but we need people who can make things work, and that involves debugging, and tenacity, and you have to just get practice with that. You get better and better at it as you do more of it. So in my career, I've gradually progressed from smaller projects that in school I understood exactly what to do, to more and more open-ended, kind of more scary projects, ultimately with 100 people working on them, and I don't know what everybody's doing. you gradually build up to that. Every level of complexity you take on scares you, but as you work through that, you're ready for the next level. So this course is a little more open-ended than the labs, et cetera, that you've done in previous courses, and that's on purpose. It's to stretch you a little bit. Okay, so I'm going to go through this really quickly because it's close to what I talked about in the fall seminar. Just the importance of what we're going through in this course. So we're teaching about software, about design, and communication. So software is everywhere. It's in your phone, your computer. It's also in all these embedded systems, planes, cars, MRI imagers, internet routers. It's in the data center, so software you don't see, where you talk to Alexa or a Google search engine. You know, you have thousands, millions of servers that are collaborating to answer questions from all around the world. This is one I didn't talk about in the fall, so I'll talk about this a little more. So deep learning and AI. So deep learning is basically applying neural networks and statistics through the creation of software to make a system that will get better with more training data. Okay, so one of the things you need to be able to do, a key thing, is to write software. You can't make that work without that. And these are just some of the amazing things that are going on in this field. The left picture here is from an OpenAI generative transformer called Dolly, or Dolly 2, and basically a person typed in a sloth playing a guitar, photograph, 35mm lens, and they got a picture of a sloth playing a guitar with roughly the focus you'd expect. It's actually kind of spooky. That's, you know, another classic application is not generating, but categorizing data, and that's driver assistance. So when your car keeps you in the lane, I mean, that's what my car does now. It keeps me in the lane, keeps me a certain distance away from other cars. It's really helped my driving record, and it's doing all of that with deep learning, recognizing the images around it at a high rate. This last example actually comes from my daughter, Victoria Betts, just because I thought it was kind of cool. So she typed this prompt into an OpenAI natural language processing transformer network, a certain kind of neural network. Write a screenplay about George Lucas writing the prequels while struggling with a crippling ketamine addiction. And it actually came back with a pretty good script. So I've shown you the first part of it. It actually figured out that, you know, what ketamine addiction would make him feel like, that Jar Jar Binks might come and taunt him, and it's actually, the script is pretty funny. So actually some pretty amazing things happening there, and one of the skills you need to participate in that is software skills. Again, talked about this in the fall. Engineers create all sorts of specialized software that no one else will make in order to help create their designs, so they can optimize in software rather than building many, many physical prototypes. These are two pieces of software that I've written in or worked on in my career. One is simulating Maxwell's equations, and in this case, optimizing an MRI machine's magnets, and on the right, optimizing a type of light-activated chemotherapy. And the last example, we work at scale. If you're building computer chips, you're building power networks, you tend to be building things with a lot of components. Computer chips is probably the best example of this. You have repetitive tasks that if you can automate them, you can do better. So this is a piece of software that was written by someone on my team at Altera in order to better create a chip with 4 billion transistors and automate something that no one wants to do by hand 4 billion times. Okay, so software is everywhere. It's an important skill. How do I get better at it? Anybody recognize this quote? So a great lathe operator commands several times the wage of an average lathe operator, but a great writer of software is worth 10,000 times the price of an average software writer. Who do you think wrote this? Was it George, the lathe operator? Right, he's just embittered. Why don't you click your button so I know? Let's see, I don't know what the right way to do this is. I wasn't paying attention to who keyed in first, so I'm gonna do this. Press your button now. Okay, I'm gonna take you. Who do you think said that?
I'd assume an entrepreneur related to software, someone like, I don't know, Bill Gates or Steve Jobs.
You think it was Steve Jobs? Okay, it's a reasonable guess. It wasn't Steve Jobs, but close. Anybody else want to take a guess? So I guess as a hint, it is somebody who knows something about software. It's not George, the lathe operator, being bitter about software. B10. So B10, your mic should now be green, so you're on the air. Oh, you got to take a guess now, right? Just take a guess. Okay, I'll let you out with that one. Okay, one last team. Let's go to B9. B9, what do you think?
I think it's Elon Musk, probably.
No, it's not Elon Musk. Okay, so it's, okay, let's see. Okay, I'm going to clear it out. It's actually Bill Gates. So obviously famously successful founder of Microsoft. If you actually know his life story, so if you just, I know there's a lot of disappointment. You're like, I almost got it. We're going to move on. Bill Gates is actually an extremely talented programmer. Okay, so before he was, CEO running a huge company, he was an extremely good programmer. That's how he built his company. And actually, a key to that is that he had access to a mainframe at the University of Washington when he was a high schooler. He had way more experience programming than almost anybody at that time, because PCs didn't exist yet when he was first getting his programming experience. So the best programmers are really good. There are many studies, this is an old one, but many studies have confirmed this. The best programmers are more than 10x above average. That makes them valuable. This is a valuable skill. You get a lot done in your career. You can get a very good job because you keep getting better at it for so long. Now, are these programmers born? No, they're practice. So Bill Gates had a ton of practice. This book, Outliers by Malcolm Gladwell, looks through a very large number of people who are exceptionally talented in their field and finds that a common thread is they have a huge amount of practice. So people overestimate the importance of innate ability and underestimate the importance of practice. So you want to get good at something like a musical instrument or software, practice. So that's part of why you want to do this. You can get good at it, and it's important. The first thing that where you may use these skills outside of a university, design and communication, is in getting a job. So your transcript is going to tell an employer, do you know the basics? And I am speaking about this as someone who's hired hundreds of engineers, so I'm not guessing when I say this. That's important, right? So the transcript is part of the screening process, but it's not enough. Your resume in the interview says, are you the right person for this job? And what I want to find out when I'm interviewing someone, what the other people who recruit engineers that I know want to find out is, can you design or can you problem solve? The transcript tells me if you can learn the technical material. I need to know if you can solve the problems we're going to give you, which are not in a textbook. Can you innovate on your own? And can you communicate? If you can't explain to me how to solve that problem, if you can't work with the rest of the team, I can't really use you either. So these are the two key skills. So my favorite interview questions, one of them is, what is your proudest design achievement? I used this when I was at Altera. I use this in recruiting grad students. So I get some great answers. I don't care exactly what they did, but if you can see the passion, they dug into it, they learned on their own, that's a great sign. And a bad sign would be to say, I got 100% on this test, right? Because it's not a design achievement, right? That's repeating back some analysis. It's different. Another one, describe a difficult debugging problem you faced. Why do I ask this? Because no complex system works the first time. So I need to know that somebody that I'm hiring is going to not run away when that happens, but dig in, okay? They're going to go, okay, yeah, this was a challenging one. I really remember this. I tried this, I investigated that. It wasn't that, it was this other thing. I figured it out this way. Okay, that's telling me when it gets hard, this person is actually going to dig into it. They like it, they have experience in it. So it's such a key skill that I ask about it. And you don't develop those skills out of a vacuum. You develop them by practicing. So you're going to do a bunch of debugging in this course, and don't treat that as, why do I have to debug? I just want to write software and have it work. That doesn't happen. So you have to develop those debugging skills. Okay, that's kind of early in your career, getting a job. What about building your career? Well, in many courses, you're going to analyze how something works. But in your career, you're going to want to go beyond that. You want to create your own creation, which is design. You still need your analysis skills. You're going to analyze the choices, but there's more creativity in design. It also requires breadth. So design tends to combine ideas from various areas. So taking a lot of different topics, synthesizing them makes you a better designer. You also are going to need to communicate in many ways in your team. Within your team, with typically fast, informal status meetings, to your management where it's more high stakes, more formal, and then to clients and customers where you really got to convince them I'm the right person or I'm the right company. A couple couple more stories just from my own career. So I told you I co-founded a company, and key to our success were both design and communication. So the design part, our company was to make better computer-aided design tools like Cordis for field programmable gate arrays, the chips that you're using in 241 and 243. And we succeeded, okay? So one of our customers was Altera, so we were a separate company at that point, and they benchmarked our software against theirs, and it was 30 times faster, so instead of taking 8 hours, it took 15 minutes, and it made the chips run 38% faster on average, which meant they could charge about twice as much. So that was valuable to them. So they paid us $2 million US for the prototype software. So they were excited enough about the prototype, they bought it, and we were proud of ourselves, we had done well. And then they wanted us to write software for their next generation chip. And this was now where our communication opportunity was. We presented to their CEO and chief operating officer that basically you have the wrong chips for our software. So we can write software for your next generation chip, but that's not what we should be doing. What we should do is we should design your next generation chip and write the software for it. Which was a big pitch, you know, for the startup to say all of your technology should really be done by us. And we had to convince them that this is going to be worth a lot of money because we'd like them to pay us a lot of money, right? And we were successful. So they ultimately decided to actually buy the company because they decided that actually the pitch made sense, but they also decided this is really risky to have some outside company designing all our technology. So this is the highest stakes presentation that I've ever made. And yeah, maybe if I went back in time, I would have tweaked it some more, but it went okay. Okay, so that was all motivation. Why is what we're teaching you in this course and the skills you're getting important? Let's talk quickly about the mechanics of the course. You're building a mapping application, so this is a reference solution, visualizing in New York. I'm not going to go through this in great detail. There's some more information in the syllabus, and you'll get lots of detail on this as we go through the course. But the first couple of things you're going to do, which you can start on and should start on right now, are individual. So we've released a milestone 0 where you learn how to use the software tools. It's not terribly difficult, but you don't want to race through it. You want to actually learn how these tools work because it's good for your career, good for the course. And Dr. Chong, or Professor Chong, will talk more about written document 0 and reading made to stick. And then the rest of the assignments are group. So do those in a team of 3. And I'm not going to talk about them in detail, but there'll be 4 milestones for software and an additional written document and 2 oral presentations. Grading is no final exam. You can see all the details in the syllabus of where the grades come from, but basically about half of the grade comes from software design, and about half of it comes from communication and project management. They do help each other. If your team communicates well, you'll probably do better at making a good design. If your design is good, it's easier to make a nice presentation about it. You're going to be mentored by a communication instructor who basically represents your project manager. They don't care about the nitty-gritty details so much of how you're doing something technically. They care more about how is the team organized, what are you trying to achieve, and how effectively you communicate. You're also mentored by a TA who's an engineering grad student and basically represents an engineering manager. Cares a lot more about the details of exactly how are you making it work. For the next 2 weeks, the labs are going to be individual. So as I said, milestone 0 is out. Go look at it. It's not very hard. It's debug a program and use a bunch of software tools to help you do that, and store your software in what's called a version control system. So none of that's terribly hard. It's intended to make you read the guides of how these things work and get some experience with them. Don't race through it as fast as you possibly can, because that'll make it harder in the rest of the course where you go, I don't really know how these tools work. The 2 most important tools to learn are Git, because you haven't used it before, and we'll talk about that in the next lecture. That's a revision control system to organize software changes, and the debugger. Now the debugger, you hopefully have used before in 105 and 244, but in practice I find many students haven't used it very much. You want to start using it now. It'll be important in this course, it's important in your career, it makes you a lot more productive. So take the time to learn how to use it. You'll work on the ECE, what are called the UG machines. There's information on the course website, but basically you're going to log in with your UTOR ID. Your initial password is your student number. You should change it right away with this password command. You can work in the labs anytime, well, during the lab period, but also anytime you get in and there are computers available. You can also work at home using a remote windowing software called VNC, or you can download essentially a copy of the whole undergrad lab computer setup called a virtual machine and work on your home computer without a network connection. So you've got multiple options. All of that is on the course website. Okay, so right now, you're doing the first couple lab periods individually. After that, you're working in a team, so you have to form a team. So you're looking for teammates. You have to be in the same time slot for your lab, which will also mean you're in the same time slot for your tutorial. You want to think about this carefully. Try to choose people with the same work ethic and goals. You don't want to basically have somebody who is just trying to get a perfect mark and really wants to fine-tune everything, and you're saying, you know what, I just want to bang it out relatively quickly because I want to focus on my other courses. That would probably not be a great match. Complementary skills. So maybe you can write really well, this other person's a great software programmer, or maybe you're both kind of reasonable at each. And make sure you can get along. You know, you trust the person. I don't mean get along like your best buddies, but you trust this person, you believe that your working styles are compatible. You can use Piazza to find teammates. There's a posting there where you can say, I'd like a teammate in this time slot. And once you find them, there's a little guide on the course website on how do you enter your team in Quarkus. If you can't find a team, Professor Chong will help you in the week of January 23rd. So don't panic if you can't find a team, but this gives you a chance to choose your teammates, and often teams are kind of more compatible if people have chosen their own teammates. Okay, from January 23rd onwards, you're going to meet with your TA in the lab. You're going to meet with your CI at some time you choose. It might be during the tutorial time, it might not. We expect you to meet with your TA and CI every week unless you cancel in advance, and we expect you to be prepared. So we'll talk about this as we get into the team part of the course, but we want you to have a written status on a web page called a wiki, and 2% of your mark is going to come from being prepared for your CI meeting, being professional as a team member. And there are bonus marks available if you make exceptional contributions on Piazza, so you help out your fellow students when they're struggling, or in the lecture or in the tutorial. Tutorials. So the tutorials in this course are teaching you important information. You should go to them. The first 2 weeks, we're teaching you a couple of important C++ concepts you haven't gotten to yet, and you need them to be able to code productively enough to complete this project. So you really want to go and learn those things. There are 7 more tutorials, so there isn't one every week, but there are tutorials most other weeks. And those ones tend to be kind of hands-on. How do I attack this next milestone? How do I debug this milestone, etc. So also very helpful. We'll post the slides and the video for the tutorials in case you missed part of them because your CI meeting is at the same time. Okay, academic integrity. So your whole mark in this course comes from the project and the communication. So academic integrity is even more important in this course than it is in most, because it's very important that people are submitting their own work on all those assignments. Don't share your code with anyone outside your team. Don't look at or incorporate code from some old 297 project that you found online or got from somebody in a prior year. So all the written reports are run through our original. All of the software is written through a plagiarism detector. We keep every milestone that's ever been submitted in this course and compare to them. And the checker is very good. And you get penalized. As soon as we find this, it gets referred to a very scary procedure with the Academic Integrity Office, and both the person copying and the person who enabled it are punished. And the punishments are severe. Very few people fail this course because we want you to succeed, except those who plagiarize. And unfortunately, every year there will be several students in the past who would plagiarize and will fail the course. So it's not a good idea. It's not, and that's kind of the, you won't get away with it and it will cause you problems. It's also on a moral level not a good idea because it's unfair to your classmates and you're reducing your learning, right? This is You're here to learn, right? Not to get some number. This is a quote from Warren Buffett. It takes 20 years to build a reputation and 5 minutes to ruin it. And Warren Buffett lives by that. I mean, I've read his biography. There's lots of interesting articles about him. If you have an ethics violation, he is very harsh on you. Berkshire Hathaway is run to a very high ethical standard. He's very compassionate with his employees if they just make mistakes, but not if they are ethical mistakes. It's a good thing to live by. My former boss at Altera also used this motto, right? Be really careful what you do in a moment of crisis or stress, because that could destroy your career. Resources and advice. Your CI and TA are mentors. Ask them for help. Piazza, we respond very quickly usually to questions on Piazza. Ask anything. Don't post large amounts of code or solutions unless it's a private post. So you go, I might be revealing too much of my solution here, then make it private. We'll see it, other students won't. Dr. Chong and I want to be as accessible as we can, so we each have a coffee hour where we're on Zoom. I'll also be in my office. Dr. Chong, I think, will also be in his office, so you can come physically or you can just have a virtual coffee with us. You can email or do a private Piazza post to schedule extra meetings if you need them. Feedback. Okay, so Piazza, you can be anonymous to your classmates, but you're never anonymous to the instructors, so it's maybe useful to know. It's never fully anonymous. But there is an anonymous feedback link on the course website, so if you have constructive feedback, type it in there. I guess if you have non-constructive feedback, we can't help you. We can't stop you from sending it in, but you'll probably just hurt our feelings, right? We want to find ways to improve the course, so a mistake bounty. So the first thing, you find a bug in the software, we want to know about it, you post that on Piazza, we'll give you bonus marks, okay? So we keep track of that for the participation mark at the end. If you point out a mistake in lecture, I'm going to give you a chocolate bar. If you find 3 mistakes in one lecture, I'll give everybody a snack-sized chocolate bar, okay? So my wife buys these chocolate bars for me, so she insisted snack size for the class. And I did have to do this actually a couple years ago, so it's a lot of chocolate bars. So you'll be a hero to everybody if you kind of find 3 mistakes in the lecture. And it helps everybody. We can make it better. Okay, so this course does have more open-ended workload because it's designed. So is it a hardcore workload? You might have heard of this email, all right? And you might have heard of this person who is now running Twitter. So going forward to build a breakthrough Twitter 2.0 and succeed in an increasingly competitive world, we will need to be extremely hardcore. It means working long hours at high intensity, only exceptional performance will constitute a passing grade. How did this go? And did this go well? Did this go poorly? So you ought to weigh in. Okay, so B09, you are on the air. How'd it go?
It didn't go so well. A lot of employees left.
Yeah, he's actually achieved 75% attrition at Twitter within a few weeks. So when I was at Altera, we had targets of less than 5% attrition, meaning people leaving the company in a year, because it's actually really disruptive. Somebody knows a lot about technology, they're not easy to replace. And I was proud that the Toronto office actually generally achieved that. I've never seen anything like 75% attrition in a month, right? It's insane. So no, we are not doing this. So we are running this course. You may notice we are not Elon Musk. Okay, we do not expect you to have some hardcore workload. There will be times where you're working hard on some of the assignments, but as I said, don't shoot for perfection. You got to balance. So what do I mean by that? A design course like this, we want to stretch you, but not stress you out too much. Okay, so what do I mean by that? This curve is one that I found online. It's a common representation of as you increase the pressure, and pressure can be all sorts of things, right? In this case, it's doing something you haven't done before. What happens? If there's no pressure, then you're over here in this boring zone. It means you're getting bored with school, you're getting bored with your job. This is when people quit. They're not learning that much. It's easy, but they're not learning much. If you're over here, this is where you go, I have no idea what I'm doing. There's like stuff everywhere, I'm panicking. You're also not learning that much, you're not very happy. Where you actually want to be is what they call here the ideal zone, where if you're stretched, so in other words, you're doing things where you go, I haven't done this exactly before, but I believe I can do it. I'm attacking it. It's a bit stressful, but I can handle it. That's when you're learning the most. That's where we want you to be. Part of that, managing that, is managing your own expectations. Part is talk to us, talk to your TA and CI, because if you're not in that zone, that's kind of where we'd like you to be. This is very true. I found this in my own career. So in my own career, whenever I found my job was getting too easy, essentially, I didn't go to my bosses and say, hey, my job is too easy, maybe you should cut my pay or something like that. But you realize you're getting kind of bored. You're actually able to do this without too much effort. And whenever that happened, I would change something. Take on a new project, move to a new job, because it's nice to keep learning. But it comes with some amount of stress. Okay, and with that, I'm going to hand it over to Professor Chong.
Okay. So I'm sure you're happy to be getting your first assignment on the first day of class. Unfortunately, we do want to get you started very quickly because it involves reading this book, Made to Stick. And I'm going to talk about written document 0, which is the ideas about what makes ideas memorable. And I'm going to break down the assignment very quickly. So essentially, it asks you to take 3 principles from this book, and there are 6 key principles in this book, right? And apply it to one of these keynotes. Okay, so we've given you a selection of 3 keynotes from Apple, Google, and Microsoft. So we have the talk with Satya Nadella and the CEO of OpenAI in the Microsoft Ignite talk. We have the Google I/O keynote, and we have the keynote from the introduction of the M1 chip from Apple. Okay, so we have that, and you have these 3 principles, and you have these sections of the talk. And you're being asked to apply these principles to one of these 3 presentations. Okay, they're 11-minute segments, and you're either outlining how a principle was used, okay, or how they could be used a little better to make these presentations sticky or stickier, right? So essentially, you're either taking an approach where you're analyzing how they used a principle, or you're saying, oh, they could have used this principle to make their presentation a little bit better. And we've given you a little bit of choice here because I think it's nice to have a little bit of choice. You might want to look at all 3 of these segments just to get a sense of what they all look like before you make a decision. But again, this is just a 400 to 600 word assignment that is due on January 28th. And the assignment is up. You can read about it in a little bit more detail. Now, what we can tell you about how this might look is, well, we can look at what we tried to do at the beginning of the lecture. I'm not sure it was super successful, but we tried to apply a couple of these principles, right? So 2 of the principles in Made to Stick are unexpectedness and concreteness, right? And unexpectedness is an attempt to surprise the listener or the reader or give them something that they don't expect so that they tune in and they start listening. Concreteness refers to the attempt to show them something rather than just tell them something. So don't do something abstract or talk about something, but actually show them what it looks like. And we tried to do that by having Professor Benz present poorly for 30 seconds. Unfortunately, he's so good that it didn't come off as well as it should have, okay? But both of these were really in service of the idea that communication really matters. And if you look very closely at the Made to Stick principles, okay, right? You can say certainly we did something surprising at the outset of the lecture to get your attention. And then we showed rather than told you about an example of poor communication, okay? But what's key about the way that they define these concepts is that it has to happen in a way that's connected to the core idea of the lecture. Okay? So it's not necessarily just me appearing in like a chicken suit or something that's unexpected in that way, but it's connected to the core idea of a lecture. And here we followed up on that concrete experience by discussing its impact on its impression of our authority. Okay? So I'm going to go through these a bit quicker. I just want to talk about what Made to Stick is. And Made to Stick isn't intended to be a writing or communication manual where you just tell people how to do something. Okay? In fact, it's more a book around social psychology and behavioral economics that really focuses on both how and why these techniques work. And why do we want you not to just understand the techniques, but why they work? Well, because when you're applying these techniques, right, and you're using your judgment to apply these techniques in a certain way, it's really important to understand how they operate, why they work, in order to make sure that you're using it correctly. Okay? I'm going to say very quickly that, you know, this looks like a big textbook, big book to read. It's 200 pages or so. And so it's going to be very tempting to kind of simplify or read summaries of what they've provided. Okay? And when you break down the concepts, they're really these 6 core concepts, right? And they're they seem like they're pretty simple, right? So I don't have to read the whole of the book. Well, in fact, if you just look at their first principles,